Simplifying rational expressions. We're going to be doing a lot of factoring here, so we haven't gotten away from that. And then the other thing is these expressions are fractions. So something that we need to keep in mind is that the bottom can't be 0. So we don't want this. So before we even think about factoring or simplifying, we need to check and set the bottom equal to 0. So that means g in this case cannot be negative 4. Because if we plug in negative 4 for g, then the bottom will be 0, and then we have a fraction being divided by 0, which we can't have. And that'll become more necessary when we start to graph these. So that's the first thing you should look for, and then see if you can factor and then reduce anything. In this case, this is its simplest form. With the exclusion, g cannot be negative 4. So looking at number 2, we're going to do the same thing. Right now the bottom, it's a little hard to tell what x can't be. So when we're doing the work, we can start factoring. I could take out an x from the bottom. Okay, I'm not getting rid of it, it's right here. That's what the bottom has in common. Minus 15. Now remember, these two are the same thing. I just factored the bottom. Nothing cancels out, so it has the exclusion of x can't be 0 or 15. All I did was set this equal to 0 and this equal to 0. Let's try one more. Looking at the bottom, it's hard to tell what y can't be, so we can just go ahead and factor a while. Well, multiplies to positive 4 and adds to positive 5. That's y plus 4 and y plus 1. Nothing cancels out, so this is our reduced, as far as it can be reduced, answer. And then the exclusion, y can't be negative 4 or negative 1. I just set the bottoms equal to 0. So this whole thing would be our answer. So this next part we're actually going to do simplifying, but we still need to check for exclusions. So for number 4, start with a simple one here. We have an r on the bottom. So just from this, r can't be 0. We might be able to add on to that later, but for now, definitely r can't be 0. So the next thing we look at is we can reduce 2 over 14, and we can reduce r to the 4th over r. Well, I know 2 over 14 reduces to 1 over 7. I'm not going to put the 1 up there because I know I'm going to have r's left over. So r to the 4th over r is r cubed, with the exclusion that r cannot be 0. And this is our answer here. For the next one, if we set this bottom equal to 0, that means n can't be negative 1/2. So that's something that we need to keep in mind. So now when we simplify, that means we need to factor the top. So that means we could take a 3n out. And we're left with a 2n plus 1 all over a 2n plus 1. Well, if we're looking to cancel anything out, this particular problem has 2n plus 1 on top and bottom, so anything over itself will cancel out. So this is gone and this is gone. We are just left with 3n over 1, or just 3n, with the exclusion that n cannot be negative 1/2. So we still got to drop this down, and that is our answer. Let's try these two more. Number 6, it's hard to tell what the bottom can't be, so let's start factoring. 1 multiplies to 6 and adds to positive 5. Oh, that's 3 and 2. These two will end up canceling out, but before we cancel out, we have to make sure that we know that x can't be -3 or -2. So that's going to be part of our answer at the very end. Now we can go ahead and cancel out the x plus 2's. So we're left with a 1 on top. We need something there since everything cancels out. And then the x plus 3 on the bottom. With the fact that x can't be -3 or -2. And that's our answer there. If you want to give number 7 a try, pause the video, and then I'm going to do the work here in a second. So I can't tell what the bottom can't be, so I'm going to go ahead and factor everything right now. Might as well. We can take care of the top. That's a difference of squares, so that turns into w minus 2 times w plus 2 over, now I got to find out what multiplies to 12, adds the -8. Oh, that's w minus 6 times w minus 2. These will eventually cancel out, but we got to keep in mind that w can't be 6 or 2. So now we can go ahead and cancel out anything that's over top of each other. W minus 2 will cancel out. So we're left with a w plus 2 on top over w minus 6, with the exclusion of w being 6 or 2. So we have simplified, and then we're including our exclusions there. So that is simplifying rational expressions. If you have any questions, please raise your hand. Give the practice a try.